This is part 2 of lesson 3.1, and this is examples 6 and 7. In example 6, you will use special angle pairs to find values when locating parallel lines cut by a transversal is more challenging to do. So let's take a look at example 6. Example 6 is using the diagram at the right, find the value of x. In here we have, looks like a triangle within another triangle, but notice that we have two line segments that are parallel to each other. Anytime you have two or more line segments parallel to each other in any figure, then always a little red flag should go up in your head and reminding you of what we learned in this lesson about parallel lines cut by transversals. So we've got these two parallel line segments, and then we've got this angle right here, which is 3x minus 10 degrees, and we've got this angle right here, which is x plus 40 degrees. Take a look at these two angles. Now, I can tell right away what kind of angles these are, but when you're first doing this, sometimes it's kind of hard to figure out what angle pairs there are. So one little strategy you can use until you can do it without it is extend all the lines that contain those angles. So if I extend this side of this triangle here this way, and I extend these two, since they're the two parallel line segments, this way and this way, and maybe draw an ellipse or circle around that, and if you just zero in on that, can you see the two parallel lines cut by a transversal? Here are the two parallel lines, here's a transversal, and you can hopefully readily see what kind of angles those are. Those are corresponding angles because they match in position. Lower left, lower left. So, here, by the corresponding angles postulate, and they didn't ask us for this, but I'm writing it down to help you for your notes. Sometimes they will ask you for it, and you'll have to write it down. Anyway, by that, we know that this angle is congruent to that one, therefore their measures have to be equal. So I'm going to set this equal to that. 3x minus 10 degrees has to equal x plus 40 degrees. And we solve for x. Drop the parentheses, and we've got x terms on both sides. So subtract x on both sides. 3x minus x is 2x minus 10 equals 40. Then add 10 to both sides. We have 2x equal 50. Divide both sides by 2, and x is 25. Now, they only asked us to find x, and that's exactly what we did. We're finished. They may ask you to find an angle later. You would just substitute that back in here or here. Example 7, in the last example. In example 7, you again will use special angle pairs to find values when locating parallel lines cut by transversal, and that's a more challenging thing to do. So, example 7 says, using the parallelogram at the right, find the measure of angle A and the measure of angle B. Now, a parallelogram, if you'll remember from 8th grade or 7th grade or 8th grade geometry, means that all four opposite sides are parallel. So these pair of opposite sides and these pair of opposite sides are parallel. Went ahead and put the parallel symbols on there, but if they hadn't, you still should know that they're parallel because it says parallelogram. Alright, so this angle A here is 4x plus 13, and angle B is 3x minus 8. Now, what is the relationship between angles A and B? Which parallel lines do you use? So, remember the last example, we used a little technique that I'm going to use on this one. Take the lines of segments associated with those angles and extend them. Notice this has to do with both the angles, so I'm going to extend it in both directions. So I'm going to go this way with it, and this way with it. And also, line segment AD and line segment BC have something to do with this angle and that one. So I'm going to extend these going these two directions, here and up here. And right here, you see that you got two parallel lines cut by a transversal. They didn't ask for this, but if they asked you to state the transversal and parallel lines you used, you would say something like this. You would say line BC, or segment BC, is parallel to segment AD. You'd use those two, cut by transversal AB, segment AB. But anyway, those are the ones we're going to use. So we're really going to kind of ignore CD on this one. All right, what kind of angles are those? Well, they're inside the two parallel lines that we're using, and they're also on one side, or the same side of the transversal, so same side interior angles. So by same side interior angles theorem, do we set these equal to each other? No, we don't. They're supplementary. Same side interior angles are supplementary, so we have to add both these two measures and set them equal to 180 for supplementary angles. So 4x plus 13 degrees plus this one here, 3x plus 8 or minus 8 degrees equals 180 degrees. So dropping the parentheses and combining like terms, 4x plus 3x is 7x, and then plus 13 minus 8 is plus 5 equals 180. Solving for x, we need to subtract 5 from both sides, so 7x equals 175. Divide both sides by 7, and x is 25. Now they didn't ask for us to find x, so I'm not going to box it in, but we are going to use it. Now for the measure of angle A, they asked us to find, it was 4x plus 13 degrees. So substituting in 25 for x, we have 4 times 25 plus 13 degrees, which equals 100. When you multiply those together, plus 13 degrees, which equals 113 degrees. So the measure of angle A is 113 degrees. The measure of angle B was 3x minus 8 degrees. So substituting in x equal 25 again, we have 3 times 25 minus 8 degrees, which equals 75 minus 8 degrees. So the measure of angle B is 67 degrees. So the measure of angle A is 113 degrees, the measure of angle B is 67 degrees, and you have finished the problem. This is the end of part 2.